Okay, good afternoon. This is Dr. David A. Padgett. Today is March 1st, first day of March 2021. This is World Regional Geography 1010, Section 98A. And we are going to begin a new unit today. We're finished with Unit A. You have hopefully finished taking the Unit A exam. And now we're going to move on to Unit B, which covers North America. So I'm going to share my screen. And if you notice we go to student view here. And if you notice that the link to the reading assignment for Unit B is up, and you see that the first part of, well, the first aspect of North America that we will examine, of course, is the physical environment. And so please familiarize yourself with chapter 12, specifically these figures, figure 12.1 on page 528, figure 12.3. And you've seen those already. That's the physical map and also the climate map and some of the other maps. So I'm going to begin by looking at something that is very familiar to most of us, and that is climate. So we're going to actually start there with figure 12.3. Okay, so we're going to go to the textbook. Here. And so if you remember, figure 12.3 is a climate map. It's also a choropleth map. Choropleth map, remember, uses color area symbols to visualize data, color area symbols. So remember the Kirpin climate system that you've seen this before is a alphabetical system starting with A climates, which are tropical, rainy climates. B climates are dry climates. C climates are subtropical climates. D climates are temperate climates. E climates are boreal climates, and F climates are polar climates. And if you remember going back to the choropleth map, each area on the map that is represented by a specific climate has a specific color. So I'm just going to walk through first some of the climate regions, because that's what we're most familiar with. We pretty much are familiar with the weather and climate in the areas in which we live. We know how to dress for certain climates. We know how the seasons change across certain climates. In some places, the leaves fall off the trees and turn colors in the deciduous forest, and so on and so forth. But okay, so let's start off with A climates. If you notice, the only place that we really have A climates in the United States is right here in the southernmost tip of Florida, Broward County, Miami-Dade County, maybe Fort Myers, Key West, of course, and in Hawaii also has A climates. A climates come in two varieties. One is permanently rainy. When I say permanently rainy, that means that there's rain every month throughout the year. Notice there's also an AW climate, which is a summer rain, winter dry climate. In these AW climates, that's when we have seasonal precipitation, and we'll see more of those climates when we get into the next unit C, when we start to examine Latin America and the Caribbean. Again, not so much of that in North America. And of course, we have uh, something that's called a monsoon climate, which is where there's a lot of precipitation during one part of the year and then very dry during the other half of the year. Not a whole lot of that happening at all in North America. So we'll just go in order. So here are A climates. I will ask you on an upcoming quiz which states have A climate or fall into the A climate regions. You should know that. Next, let's look at B climates. B climates are dry climates. We have steppe BS climates and desert BW climates. So a desert is defined as a place that receives less than 10 inches of rain per year. A desert is not defined by temperature. Now, the two main aspects of climate are precipitation and temperature. When we describe a climate for a place, those are two things that we talk about the most. How much precipitation occurs, what form of precipitation occurs, and what's the temperature. And those are the two main elements of climate. But a desert is not necessarily defined by temperature, it is defined by precipitation. So these regions here in the southwestern US, those are deserts. They receive less than 10 inches of precipitation per year. Say, for instance, Las Vegas, Nevada, Phoenix, Arizona. Those climates tend to be, I guess, if I'm going to be subjective, very hot. Specifically, maybe in the summertime, it gets up to 108, 110, or even hotter. Sometimes in Phoenix, Arizona, it gets 114, 115. Very hot, but also very dry. There's not the level of humidity that we experience here in the Southeast. And a lot of people are fooled by that. A lot of people go to Las Vegas or go to Phoenix, Arizona, or someplace like that, and it's 102 degrees Fahrenheit or 108 degrees Fahrenheit, and people they're walking around, they feel like, hey, I feel good. It feels hot, but I'm not even sweating, right? So we feel good when we don't perspire. We don't like to perspire. But perspiration is our body's warning system that says, hey, you're losing moisture, you're losing water from out of your body, and our bodies need water. But if there's no warning, if we're not made to feel uncomfortable, then we feel good. But feeling uncomfortable helps us because it tells us we need to change what we're doing, i.e., you need to drink some water. So you feel icky and sweaty, but if you want to change the situation, you need to drink some water, right? But in a very hot and dry DW climate, what happens is as soon as the water leaves your body, it evaporates. So you don't feel it. You don't feel sweaty and funky. You feel good. Somebody might ask you, hey, would you like to have a drink of water? You'll say, no, I'm good. I don't need any water. And next thing you know, you pass out. And that's what happens to people. So you have to be very careful in those very hot and dry climates because it's easy to be fooled into thinking that you're not losing moisture, but you actually are, but you don't feel it, right? But it's not just the heat of these desert climates that should cause us to be concerned. First of all, it's not hot all year long in Nevada and Phoenix, Arizona. Now it doesn't get cold. Now in Las Vegas in Nevada, it does get chilly, and in northern Nevada near Reno, they get quite a bit of snow because there's a higher elevation in Reno than in Las Vegas. But So it's a lot of, some people go to Las Vegas. Oh, we're gonna go to Vegas for New Year's, and they get out there thinking it's gonna be pool parties, and they get out there and it's like 50 degrees Fahrenheit. Like, wait a minute, this is Las Vegas? Yeah, I mean, it's not hot there all year round. It's not like Miami, right? Now, but in terms of temperature and health, not only is heat dangerous, um, the 24-hour temperature range in a desert area can be quite wide. In other words, during the day, it might be 95 degrees Fahrenheit. At night, it might go down to 45 degrees Fahrenheit on any given day. And so, why is that? How is that dangerous? Well, what happens to people a lot is they go out to Las Vegas, and there's more things to do out there besides gamble. There are lots of places to go nature hiking, especially out to Red Rock Canyon and places like that. And there's places all around Phoenix, Arizona, to go hiking in the desert if that's what you want to do. And a lot of people do like doing that. But what happens is people get out there maybe in the middle of the day, in the afternoon, and it's 95 degrees outside, 95 degrees Fahrenheit, and they have on their shorts and a little t-shirt and some, maybe not flip-flops, even if maybe hiking boots, tennis shoes. And if you've never been out in the desert area, it's very easy to get lost. Everything looks the same after a while. And if you're walking around oohing and ahhing and not paying attention to where you're going, it's very easy to get lost. Now you're out there, you're in the desert, you didn't take a paper. Well, maybe after you take this class, you'll take a paper map and your cell phone. But let's say some people didn't take this class or any other geography class, went out there with the cell phone. Now you're walking around lost. Oops, no service. Oops, phone dies. Now you can't get back to your car. You're wandering around. Starts off at 95 degrees. Eventually, if you're still wandering around out there at night, now it's 45 degrees Fahrenheit. And you might think, well, that's not too bad. 45 degrees Fahrenheit. Just tell that to the people who suffered through that ice storm in Texas last week. Inside of some of those homes, it was 45 degrees Fahrenheit, 50 degrees Fahrenheit, which probably doesn't seem that cold. That's not like 14 degrees Fahrenheit like we had here, in 6 degrees Fahrenheit like it was in Dallas, Texas. You might think, well, 45 degrees Fahrenheit, that's not too bad. But think about it. There's no shelter out in the desert. There's no place to hide. You're just out there in shorts and a t-shirt. And if you're out there too long, 45 degrees can kill you. It's called dying of exposure, not freezing to death, dying of exposure, because your body is supposed to be, your core temperature is supposed to be 98.6 degrees Fahrenheit. And if you are hanging out in a shorts and a t-shirt at 45 degrees Fahrenheit, it could be very bad for you, So you have to be very careful. And not just to be scary and all, but even if you just happen to be in Las Vegas or Phoenix, Arizona during certain times of year, you should dress in layers. You have your short and t-shirt on, but always take a jacket or a sweater or something, because at night it can get a little bit chilly. You'd be surprised at how chilly it gets at night in these desert climates. Now, the other B climate is that we see in North America is the steppe. A steppe is just another name for grassland. And so this BS, that's where we find the Great Plains region. So just a point of information, one of the things that you'll have to do is cross-compare some of these maps. So for instance, I might ask you, what is the climate type that is dominant in the Great Plains region? You would say BS steppe. I was ask you, what is the climate type that is dominant in the Great Basin? The Great Basin is this region here in the Southwest where you have Utah, New Mexico, Arizona, so on and so forth. Very dry and also relatively high elevation. I might ask you what climate is most closely related to the Great Basin region, and you would say BW, desert climate. Well, hopefully you will. So don't just think of these maps as individual maps without connecting them to what's on the other maps. Okay. So the steppe climate, the reason that we have grasslands on the Great Plains is that the area is not dry enough to be a desert, but it's not moist enough to support trees. So the more rain that falls in the area, the greater plant diversity that you see. And so with the the Great Plains, you have uh, plains and grasslands. Another thing that you might find interesting, and I'll try to pull this up here, just to give you something called the desert wildflower. Go to the images. So if you ever go hiking in the desert, of course, most of the time it doesn't rain. But if it does, the vegetation in the desert is adapted to that kind of climate. Desert plants can survive in climates that get less than 10 inches of precipitation. Sometimes they go dormant. It's like the plants hibernate until they come into contact with water. And so what may happen is one day you might be walking out hiking in the desert, and at first you see nothing. If you see this picture here on the right-hand side of your screen, at first you see nothing out here, desert. Then you get a good rain. It does rain in the desert from time to time. And within a few minutes, all of these wildflowers just start blooming all over the place. It's really fascinating. So those plants are really just adapted to this kind of desert environment. And it's really a fascinating thing to see in person, these desert wildflowers actually adapting to that very dry climate. Okay, so when A climates, B climates, now let's get to the C climates. And this is in the southeastern United States, and that's where most of those of us in the class live, from what I've seen in general. So what are the characteristics of a C climate? When we say a C climate, what does that mean? What we have to do is look at this graphically. And so the way that we graphically describe climate is with something that's called a climograph. Some people call them climate graphs. So what you see here is a graph of climate for Nashville. So remember, the main elements of climate are precipitation and temperature. And so here we have the months of the year. And on the left-hand axis, we have temperature, and the bar graph is precipitation. And what you see here is the average precipitation received in January for Nashville is about 4 inches of precipitation. And so what this bar graph represents is the compilation of years, maybe decades, 20 or 30 years of data collected at weather stations. And then we can calculate the average precipitation per month. And that's how we get this graph. So this gives us the averages. On this particular climate graph, we have the high and low temperatures for each month in Nashville, measured at some weather station. And so, one of the characteristics of a sea climate is that there is precipitation in every month. Not the exact amount of precipitation, but there's no wet season, dry season that we'll see later on. Also, there is a relatively, not the widest temperature range, but there is a temperature range. The temperature range is the difference between the highest and lowest average temperature experienced in a place every year. So, for instance, in Nashville, Tennessee, if you look at this graph, and let's just look at the high temperatures, which is the red line. So let's see, January, the average high temperature in Nashville is about 40 degrees, maybe 45 degrees Fahrenheit. In February, the highest average temperature is almost 58 degrees Fahrenheit. In March, it's a little over 60 degrees Fahrenheit, and so on and so forth. So we go all the way up from a low of about, let's say, 45 degrees Fahrenheit for a low for Nashville, up to, let's say, 85 degrees Fahrenheit for a high for Nashville here, the high. So 85 minus 45 is 40 degrees Fahrenheit. So the temperature range for Nashville in any given year is 40 degrees Fahrenheit. It's 40 degrees hotter as the high on average in July than January. And so this is where we get the temperature range value from. And we'll show you how different that can be from place to place. So what's going to happen is when you have a quiz, I'm going to ask you, I'm going to show you a climate graph. And you have to tell me, well, is this climate graph from Nashville? Is it from San Francisco? Is it from Miami? Which city is most closely represented by this climate graph? So that's what you're going to have to do eventually. So that's the sea climate region has a couple of other very unique characteristics, and I'm going to talk about them right now. If we go back to the reading assignment, let's look at thunderstorm days per year. So here's a map. Maybe you looked at it before when you were looking at some characteristics of your hometown. Here are the average number of thunderstorm days per year for, in this case, the contiguous United States. We don't have Canada or, Alaska or Hawaii on this particular map, but most of us live somewhere or call our hometown somewhere on this map. Notice this is a choropleth map. Notice the purple here, parts of Florida, parts of the Gulf Coast, but especially Florida is the thunderstorm capital of the United States. More than 60 days, more than 80 days per year where there's thunderstorms. I lived in Florida for 5 years, and there's literally a thunderstorm during certain parts of the year. There's literally a thunderstorm at the same time every day. You can almost set your watch to it. And so what happens is you have convection. Air rises because of the heat. Florida is a peninsula. A peninsula is a piece of land that's surrounded on 3 sides by water. So there's lots of moisture around that gets caught up when that air rises. And then the air cools to its dew point. We get thunderstorms, clouds, and all the things that we associate with that. So again, Florida. Now notice that thunderstorms are not evenly distributed throughout the United States. Notice as we get to the West Coast, there's less and less and less, and we get to Oregon and Washington and California, for the most part, they don't really get thunderstorms. Now it does rain. It does rain, but they don't get the lightning and the thunder like we get here in the Southeast. And so it can be frightening if you've never experienced a thunderstorm. I remember years ago when I was growing up in Baltimore, and we have some thunderstorms about mid-range. Some friends of mine's cousins were visiting from Sacramento, California, and we were playing baseball, I think, and it was a typical July day. Clouds started billowing up, got humid, and then we saw a stroke of lightning, and then boom, 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 thunder, right? The kids from Sacramento lost their minds. One of them just started running. Another one got up under the car. We couldn't get him out from under the car. And the girl ran into the house and got into a closet. They were scared to death. They had never seen that before. A lot of us take thunderstorms for granted. But if you're 15, 16 years old and you've never seen like the sky get dark and then the lightning, and oh man, that's really scary for somebody that's never seen it before. As a matter of fact, there's actually a medical condition. I think I mentioned this earlier. Astrophobia. Astrophobia is the fear of thunder and lightning. A person can be clinically diagnosed. A person can be so traumatized by thunder and lightning that they are unable to function, and they have to be, I guess, get some kind of psychological treatment, or if they are diagnosed with the condition and they're so traumatized they can't go to work, they can use their sick leave. Have astrophobia. And if you imagine a person growing up in Los Angeles, California, and then getting transferred to a job in Atlanta, Georgia, or transferred to a job in Orlando, Florida, had never grown up with thunderstorms, and now, it can fray a person's nerves. But there's actually a medical condition associated with fear of thunder and lightning. So that's one of the unique characteristics we have in the Southeast, are thunderstorms. And of course, along with thunder, storms comes lightning. And so let me pull up a map of lightning, which goes along, which should be no surprise to you that the lightning frequency map looks very similar to where thunderstorms are, of course. Lightning is a very, very dangerous natural hazard. Lightning is hotter than the surface of the sun. Lightning is 50,000 degrees Fahrenheit. And so what causes lightning? Lightning is caused when there's an imbalance of charges in the atmosphere, and the atmosphere wants balance and tries to get that balance very quickly by rejoining those charges. Okay, so that's a very simple lesson on lightning without getting into how complex it really is. But you notice, of course, Florida, lots of lightning and lots of lightning injuries and deaths. A lot of people are injured and killed by lightning. Most people that get struck by a bolt of lightning, a 50,000 bolt of energy going through your body, most people don't make it, right? Don't make it. So it is very important that you are careful about lightning. Lightning can travel 10 miles and be deadly. That's why if you ever have been in a baseball game or football game and there's a lightning warning and the lightning is 10 miles away, or the thunder clouds are 10 miles away, and you might think, well, wait a minute, that storm is 10 miles away from here. Why are we stopping the game? Because lightning can travel that far. You could look up and see not a cloud in the sky, and some lightning might come from over 8-9 miles away somewhere and strike you. A lot of people are injured or killed by lightning because they make a very common mistake. Let's say a bunch of people are out, maybe having a cookout, maybe a picnic, whatever. It starts to rain a little bit. Looks like a thunderstorm is coming. What do people do? They run and get up under a tree. Bad idea, right? Lightning is attracted to the tallest object in any area. And if it happens to be that tree that you're standing under, when that lightning strikes that tree, it's going to jump out of that tree and strike you. A lot of people get killed like that. I think a couple of years ago, I don't think, PGA, there was a, there was the Atlanta PGA tournament. A lot of people got hurt by this lightning strike that you see here. And so what happened was the golf tournament officials told people to leave way before this happened, way before things got really bad, but people didn't want to leave. They went and stood around these trees and they got struck by lightning. Luckily, I don't think anybody was killed, but people were injured, shoes blown off, severe burns, so on and so forth. And that happened in Atlanta, I think 2 years ago. And so the main thing to do to stay away from being injured by lightning is to stay away from trees, tall objects, telephone poles, things like that. Also, you should not shower during a lightning storm. Lightning can travel through pipes and be conducted by water and can injure you in the shower. And obviously, you should stay off of a landline phone and make sure your devices, if they don't have good surge protectors, are not plugged in. Because I'm sure I'm sure all of us have had that happen. There's a thunderstorm and you have an electrical appliance and that thing never works again, right? All of us have had that experience. Now, you might be wondering, well, how do I know how close I am to a lightning strike without really knowing anything else? Well, sound travels at roughly 1,000 feet per second. So the speed of sound is about 1,000 feet per second. Okay. We learned earlier in this course that there are 5,280 feet in 1 mile. So remember, sound travels at 1,000 feet per second. Okay. And we learned that there are 5,280 feet in 1 mile. So if you're out one day and you see a stroke of lightning, and lightning always comes first, because what happens is this 50,000 degree Fahrenheit bolt of energy takes the Earth's atmosphere from maybe 80 degrees Fahrenheit to 50,000 degrees Fahrenheit in an instant, right? So when gases are heated, they expand. But if a gas, such as the atmosphere and its gases, are heated from 80 degrees Fahrenheit to 50,000 degrees Fahrenheit, that's not going to be just an expansion. That's going to be an explosion. So thunder is the explosion that occurs when the atmosphere is heated up very quickly by a 50,000 degree bolt of lightning. So you're standing outside somewhere, or maybe you're playing a game, maybe you're golfing. A lot of people get struck by lightning golfing. And you see a bolt of lightning and you count 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. Boom. So for every second, you were about 1,000 feet away from the sound of that thunder. But the sound took 5 seconds to get to where you are so you could hear it. So what that means is that if you are standing somewhere and you see lightning and you count to 5 and you hear boom, you're about a mile, approximately a mile away from that lightning. If you count 1 second, boom, then you're about 1,000 feet away from that bolt of lightning. If lightning strikes and immediately you hear a bang. You need to take cover. That's you're right there. There's no difference between the time you see the lightning and bam. You're right there where the lightning is striking. You need to take cover. Now you can go inside. If you get inside of a car, that's a safe place. But you don't want to be standing beside the car. That's not a safe place. Lightning can hit the car, hit you. But if you're grounded inside the car with the tires, you're pretty much fine. So lightning is of course associated with thunder, and it's not something that is entirely confined to the southeast, but it is, or sea climates, but it is a characteristic that is mostly associated with the sea climate region. That is thunder and lightning. Now, another interesting phenomenon that's associated with thunder and lightning, of course, tornadoes. And so tornadoes, as you can see, tornadoes, as you can see here. Let me see if I download this. Well, I can't make it larger, so we'll just stick to this. But clearly, the tornado pattern map, choropleth map, jibes with thunderstorms and lightning. So lots of few tornadoes in Florida, but we really have, this is tornadoes out here in the Great Plains. And so that area is known as Tornado Alley. If you watch the tornado chasing shows, you will learn that that's where they usually are. Kansas, Oklahoma, Nebraska. This is where a lot of those storm chasers or tornado chasers, that's where they work, out in this area. This is the area that has the most frequent occurrence of tornadoes. So if you're living here in Tennessee, you notice it's yellow. It's not that bad. You might think, oh, we're not worried about tornadoes here. I'm glad I'm not out here on the Great Plains with Dorothy and Toto, right? But well, you'd be wrong to not be vigilant in being aware of tornadoes, because while the traditional tornado alley, certainly the frequency of tornadoes occurs is much greater on the Great Plains. Right here in the southeastern United States, right here in Tennessee and Alabama and so on and so forth, we have the greatest risk of being killed by a tornado. So what we live in here is called Tornado Death Alley. I think the place where people on average get killed the most by tornadoes is Alabama. That's the state. And Tennessee is right behind. It used to be Tennessee was first, and then Alabama has surpassed us. So, well, why is it? You may think that, why do we have people getting killed by tornadoes here? Well, first, there's a concept that in geography known as population density. Population density. Population density is the number of people per unit area of land, or say the number of people per square mile. There are very few people per square mile on the Great Plains. A lot of times when you watch those tornado chaser shows, the tornado will go through a cornfield or a wheat field, won't hit anything, won't hit anybody. It's just a huge tornado, not hitting anybody. Now, every now and then, one of those big tornadoes does encounter a town. And so in the Great Plains, and so you had some of the famous ones like tornado Joplin, Missouri. This is a very, very destructive tornado. So every now and then a tornado does hit a town in the Great Plains. But for the most part, because the population density is so low, the tornadoes usually don't hit anything. Now, where we are, there's a lot more population. There's large, and so if a tornado comes through Nashville or Memphis or Jackson, as has happened in the past, somebody's going to get hurt, and unfortunately, somebody might lose their lives. We've had several in the last 10 years. I can remember several deadly tornadoes in this area of Middle Tennessee, including one that went right down through downtown Nashville. Some of you all probably don't remember this, but there was the 1998 Nashville tornado. And so, yeah, tornado went right through downtown Nashville. Here's the Bridgestone Arena. Tornado went right through downtown Nashville. You can just Google it. You can see. Of course, we all know the tornado. How could we forget that the tornado hit campus last year? Tornado hit TSU last year. I'm sure you all remember that. So 2 people lost their lives, and then in Nashville, and then several people lost their lives as it went further toward the east. So yeah, so high population density. Second is there's an unusually high percentage of people who live in mobile homes in this part of the country. Half of the people who die due to tornadoes are in mobile homes. You really don't have any chance at all of surviving a tornado, especially a large F3 or F4 tornado. If you're in a mobile home, you have no chance almost. Another factor that plays into why a lot of people, are killed on average is in this area is due to the fact that a lot of these tornadoes happen at night. And Tennessee, according to this map, leads the nation in the frequency of nighttime tornadoes. And that's how a lot of people die. You sleep. Tornado hits your house, you never wake up. I mean, and so or hits your trailer and you never wake up. So that's very dangerous. Is a nighttime tornado because you'll never see it coming. Now we do have tornado warnings and all that and radar, but it's very difficult to predict exactly where and when a tornado is going to strike. So it's still very difficult. Now, last but certainly not least, in explaining why we have a much higher frequency of deaths here from tornadoes, is because this is not a flat area. This is a relatively hilly area here. The topography is hilly as opposed to the Great Plains. So I'm sure you've watched the storm chaser or tornado chaser shows. They can look at a tornado that's 8 miles away and clearly see it. But if you're here and there's a tornado, it might be behind a hill. You'll never see it coming. It'll sneak up on you. And I have firsthand experience with that. So here's a story that you might want to take a look at. It's called Expert, that's me, sees tornado clouds up close. This was May 18th, 1995. At the time, I was teaching at Austin Peay State University. So I was living in Nashville, but I was commuting back and forth to Clarksville because I didn't want to live in Clarksville. That's another story. So I was driving on Brick Church Pike, about to get on the interstate, and all of a sudden, everything just went black. It was like somebody took a black blanket and threw it over top of my car. So I couldn't see anything. Then I heard this really loud noise. And I saw my car almost start. I had a little Nova. My car almost lifted up off the ground. I could feel it. So I made a mistake. I gunned it. I could barely see, but I could see just enough that I knew where the road was. And I turned off of the interstate and I got underneath the bridge. And says here, the wind picked up beyond anything I've seen in recent history. I parked underneath the interstate bridge at Brawley Parkway. There was zero visibility and the wind just rolled underneath. Now, I shouldn't have done that. That bridge could have, had that been a large tornado, that bridge could have collapsed on top of my car. But it's easy to say, well, if I had been there, this is what I would have done. What you should have done was, it's easy to say that when you're not there, right? You've probably, well, maybe not. This is kind of an old movie. There's an old movie called Twister. We're watching a lot of movies these days since we're quarantined, whatever is going on. Yeah, wow, 1996. So there's an old movie called Twister. It's a pretty famous film, but don't take how a real tornado is from this movie. In the movie, the protagonists are cracking jokes as the tornado goes by. They're arguing about their relationship as the tornado goes by. You know, when you're in real life, you don't have time to do anything. I didn't have time to think. All I did was react, and cuss and pray at the same time. But yeah, and what was interesting was I didn't really realize what had happened, but I got to work and the local newspaper called me because I'm an expert, and they wanted to know, well, how do these tornadoes work, Dr. Padgett? And or really, they asked me, did you know that a tornado hit Nashville today? I said, yeah, I was very aware of it. I was in it, and so that was the basis of this story. Now, if you're from Nashville and you were probably not around in 1995, but you might have, your parents might have lived here in 1995. Ask them about the tornado that hit Rivergate Mall. You all know where Rivergate Mall is, right? So that tornado went over top of my car and kept going towards the northeast and tore up Rivergate Mall and a couple in the auto dealership out there. So that was in 1995. So tornadoes are, or deadly killer tornadoes are something that's unique to the sea climate region of North America. Killer tornadoes, not frequency, but definitely the deadly variety, unfortunately. So those are just a few of the characteristics of the sea climate region. Now, when we move farther to the north, we get into the temperate climates. And one of the main differences or main unique characteristics of a climate is that, so here's Ottawa, Canada. Remember I talked about the temperature range? So if we look at the Ottawa is the equivalent of Washington, D.C. Ottawa is the capital city of Canada, just like Washington, D.C. is the capital city of the United States. And so in Ottawa, if you notice, you take look carefully at this graph, because I will ask you, where is this what climate does this graph most likely represent? A climate, B climate, D climate, or C climate? Now, notice that for this map or this graph, for this climate graph, the average monthly low for January, so this 1 stands for January, 2 is February, 3 is March, 4 is April, and so on. So in January, we're down around 14 degrees Fahrenheit in January. Let's just say it's 15 degrees Fahrenheit on average. Let's just say 15. And then let's say in the summer, in July, the high is right at about 68 degrees Fahrenheit. So that's a more than 50 degree temperature range. So remember for Nashville, the temperature range was 40 degrees Fahrenheit. For Ottawa, it's 50 degrees Fahrenheit. In other words, it gets very cold in the winter and relatively hot during the summer in these D climate regions. Well, you might ask, well, why is that? Well, notice that these D climates, they're at higher latitudes, but they also tend to be somewhat associated with large landmass. And so land heats and cools 5 times more quickly than water. So if you're in Ottawa or Detroit or Chicago, it can get really, really hot during the summer because that land is going to warm up very quickly during the summer. During the winter, it's going to get very, very cold for the same reasons, because that land, there's nothing to modify the rate of temperature change. But if we look out on the West Coast, we'll see something that's interesting. Now, we also have sea climates on the West Coast, but especially if we look at Northern California and we pull up a climate graph of Northern California, let's look at San Francisco. Okay, let's look at the temperature range for San Francisco, California. San Francisco, let's look at the highs, which is the red line symbol. Notice that January, you have about an average of 60 degrees Fahrenheit high. In September, the high is around 72 degrees. Only a 12 degree Fahrenheit temperature range. Well, why is that? Why is San Francisco isn't much farther north? What's unique? What's unique about San Francisco is that it's also on a peninsula and it's surrounded by water. So if we go to San Francisco, you notice here's San Francisco. Here's the Pacific Ocean and the San Francisco Bay. This area is surrounded by large bodies of water. And so because water cools and heats 5 times more slowly than land, that has an influence upon the temperature changes in the city, in San Francisco in this case. And so if you ever go to San Francisco, no matter when you go, whether you go in January or if you go in July, the temperature is going to be about the same. It's not like Chicago where you can freeze to death in Chicago in the wintertime, and you go to Chicago in the summertime and it's blazing hot there, right? So this climate graph shows that we have a narrow temperature range for in this case, sea climates on the West Coast, which are not CR climates. They're more like they're CS climates. These are subtropical winter rain climates. What do we mean by subtropical winter rain? Well, just look at the climate graph. This is one of those places that has somewhat of a seasonal variation in precipitation. So the bar graph represents precipitation. So if we start off with January, they get about 4.5 inches of rain in January. February, there's about 4 inches. March, about 3 inches. Then it starts to drop down. April, now we get almost barely an inch. May, a half inch. Then June, July, August, September, there's almost no rain for months. And then it comes back again in October, November, and December. And that's normal. That's a normal precipitation pattern for San Francisco, California. I think we also have Sacramento, California here. Same thing. Notice precipitation. Then this is in millimeters. Notice. Now, just a little bit of a clue or a hint to translate from millimeters to inches. There are about 2.54 centimeters per inch, and they're about 25.4. They're about approximately 25 millimeters per inch. So just keep that in mind, because you will be asked to convert from millimeters to inches. So for instance, notice that for January, we have almost 100 millimeters of precipitation falling in Sacramento. So if there are about 25 millimeters per inch, then that means there's about 4 inches. 25 goes into 100 4 times. There are about 4 inches of rain falls in Sacramento, excuse me, in January. Okay, so that's how. Just remember that 25 millimeters per inch, approximately. It's just as close. Okay. Let's look at. So those are our sea climates. If we go to this map, and you've seen this map before, this is a map of average daily sunlight. Some of you looked this up when you were looking at climate. Notice that again in the Southwest, in Arizona, New Mexico, southern New Mexico, most of California, they have parts of Florida. Florida, in fact, is nicknamed the Sunshine State. They have lots of sunny days per year. Okay. The reason that the motion picture industry is in Los Angeles is because of there are many sunny days per year. You can count on it. The less time it takes to shoot a movie, the less it costs, which means the greater potential for profit. The optimal conditions for shooting film is when it's sunny outside, right? And so if it's sunny outside, you can count on it being sunny, then you can get a film done very quickly, spend less money, send the film out, it'll make maximum profits, right? Now, conversely, we look at Seattle and some of these areas around the Great Lakes. They have below average numbers of sunny days per year. And so what does that mean? Well, for one thing, there's a condition called seasonal affective disorder. There are people, just like there are people who can become traumatized by lightning, there are people who become clinically depressed when there is not enough sunlight, and they have to be treated for it. They have to be treated for it. And so now, how do you treat somebody with SADS? Well, they go through what's called, light therapy, and they have like artificial light or artificial sunlight to keep them from being blue. And people don't necessarily have to be clinically depressed to have SADS. Some people just don't realize it, that during the wintertime, they're just always in a bad mood. And that can be related to the fact there isn't a lot of sun, especially if you grew up somewhere where there was a lot of sun, then you move somewhere where there's not a lot of sun, and it can really, really affect your psyche to a degree. Now notice that the Pacific Northwest is dominated by these D climates, or oceanic temperate climates. So that's the type of climate region that really dominates San Francisco, whereas Southern California is more closely associated with these subtropical winter rain climates. Now, up along the west coast of North America, we have E climates. And of course, we get into these E climates, which are boreal climates, very cold climates, not the coldest of the cold. The coldest of the cold are polar climates, these F climates, where almost nothing is able to survive up here in the north. But there are human beings, there are people, there are Native Americans who are lived in those areas for centuries. In those very extreme northern locations. Let's see if I can. So something that is very closely connected to climate is vegetation. And so here's a map of vegetation in North America. Notice that we have very diverse group of vegetation systems throughout North America. Of course, in the southeast, we have the subtropical evergreen forest. I guess the most common type of what we would call a broadleaf evergreen is a palm tree. It's green all the time. You know, sometimes when we think of evergreen, we think automatically of a pine tree. That's not the only kind of evergreen tree. Notice that in the where we are, we have something that's called the temperate deciduous forest, which is something that we take for granted, a lot of us, especially if we've never lived anyplace else. Now, I had a friend of mine who came here to go to medical school, and she was from Jamaica. So here's Jamaica, and she came to Nashville to go to Meharry Medical College. So medical college is very difficult, very difficult. A lot of people get extremely stressed and depressed. So I would check on her. I said, and when she moved here in August, she started her classes. I said, how are you doing? She said, oh man, I'm doing well, man. I'm doing well. Straight A's, man. I doing wonderful, man. They cannot stop me, man. I said, great. September, how are you doing? She said, I'm doing well, man. They cannot stop me, man. They cannot break me down, man. Gross anatomy, it cannot stop me. October, I talked to her. Same thing. She was getting straight A's. Felt great. Talked to her in November. She said, oh, I'm doing well, man, but I am depressed, man. I said, why are you depressed? You're doing great. You got straight A's. She said, there's a plague on the trees, David. The trees are dying, man. The leaves are turning yellow and red and they're falling off. It's horrible. I said, wait. That's just what happens here. She had never seen that before. You know, we take it for granted. Fall comes, leaves fall off the trees. You got to rake them up. That doesn't happen everywhere. She had never seen that before. She thought something was wrong. She thought something had gone horribly wrong. When she saw what we think of as normal, right? So the deciduous forest or deciduous trees, as you can see, they aren't everywhere. You know, they're just unique to this part of the country, southeast. Of course, when we get to this blue color area symbol, this is the taiga or boreal forest. This is a large area of what we would call pine trees, I guess. Now that's a light blue area we see here. Then, of course, we have the temperate grassland. These are the Great Plains here. And of course, there's desert, this orange color area symbol. Desert plants are adapted to places that get less than 10 inches of precipitation per year. And then we have the semi-desert, which is like the high deserts of Nevada and northern Nevada and Utah, northern New Mexico and those areas, even parts of eastern Oregon and eastern Washington are very dry, as you can see. And then to the far north, we have the tundra, which is basically frozen land, ground, permafrost, very cold, very difficult for anything to survive there as far as plants. And so there is your map of North American vegetation. So what will happen is I'll ask you what climate region is most closely associated with the um, temperate grassland, and you should say BS steppe. Or I might ask you what climate region is most closely associated with desert vegetation. That should be pretty obvious, right? So those are kind of questions that might arise on a quiz, perhaps later on down the line. So this is just part one of this lecture. Part two. So in part one, we've covered the climate of North America mainly. So you want to look at compare and contrast the climate graphs. Here's Omaha, Nebraska. Notice wide temperature range here for Omaha, Nebraska. Definitely a D climate. But look at Las Vegas. Clearly, you can see that there's not a whole lot of precipitation in Las Vegas. Pay attention to the data on on the axes. Don't be fooled. Notice that on this axis, this one only goes up to 80 millimeters. And notice that, remember, there are about 25 millimeters per inch. So every month, there's no month in Las Vegas where they get anywhere close to an inch of rain. As a matter of fact, if you notice here, you have 101 millimeters of precipitation. That means in Las Vegas, they only get about 4 inches of rain every year. I think we got 4 inches of rain last weekend in Nashville. So think about that. We'll get the entire year's worth of rain in Nashville in a day or two. So Las Vegas is a very dry desert environment. So also, here's a map of annual precipitation amounts in North America. This region here along the western portion of North America, the extreme northwestern portion of North America, is called North America's rainforest. Upwards of 100, 120 inches of precipitation per year are experienced in this region. And so just make note of that there's a lot of moisture that is associated with this region. And of course, we get into this drier region represented by these color area symbols and isohyates. Remember, isohyates connect points of equal precipitation. And then you also see here, we get more moderate amounts of rainfall in the southeast. Maybe I think Nashville, we get about 45 to 50 inches of precipitation per year on average. And it gets up to maybe 60 inches per year in New Orleans and parts of Florida. Okay, so we're going to pick it up from here next time in talking about the physical environment of North America. Does anyone have any questions at this time? Okay, so I'm going to stop recording. Remember, you will have a quiz over this material next week, first of your many quizzes. So I'm going to stop recording and right now.